Hello everyone, we're the Mavericks, and today we're excited to present our groundbreaking project, MavGrids. Our mission is to develop an advanced artificial intelligence model for electricity demand projection, including peak demand forecasting, specifically tailored for the Delhi power system. Let's start by looking at the current power consumption trends in Delhi. As you can see from our Power BI report, Delhi's electricity demand has been steadily increasing over the years. We're observing significant daily and seasonal fluctuations, with peak demands during summer months and certain hours of the day. These trends highlight the complexity of the power consumption patterns we're dealing with. So, why is accurate projection crucial? Our research shows that inaccurate forecasts lead to either power shortages or wasteful overproduction. Efficient grid management requires precise demand predictions. Sustainable energy integration depends on anticipating future needs. Economic implications are significant, affecting both providers and consumers. Accurate projections are the foundation for a reliable, efficient, and sustainable power system. Technical approach. Our approach involves several key steps. 1. Data collection. We gather historical power consumption data, weather information, and relevant economic indicators. 2. Pre-processing. Cleaning and normalizing the data to ensure quality input for our model. 3. Feature engineering. Extracting and creating relevant features that influence power demand. 4. Model development. Training our SIH model on historical data and fine-tuning its parameters. 5. Validation. Rigorous testing using cross-validation techniques to ensure reliability. 6. Deployment. Implementing the model in a scalable cloud environment for real-time predictions. Phase 7. Maintenance. Model performance requires constant maintenance. We monitor the model's accuracy on seasonal loads. It is updated regularly with new data. We provide monthly technical updates to keep the system optimized. Phase 8. Reporting and visualization. For reporting and visualization, we generate detailed Power BI reports on power consumption and peak load projection. These reports include actual versus forecasted data, as well as insights on seasonal peaks and special events like holidays and festivals. Phase 9. Server and database. All of this is handled on our server and stored in a MongoDB database. The model will operate on a web server, and data is processed and served via Fast API, making it efficient and scalable. Phase 10. Website and Web API. Finally, our website and web API provide user-friendly access to the projections. Users can view reports and even connect their energy meters to forecast their personal or business consumption. Our solution, SIH. To address this challenge, we've developed an AI model using SIRIMAX, Seasonal Auto-Regressive Integrated Moving Average with exogenous factors. This advanced time series forecasting technique allows us to capture complex seasonal patterns in power consumption, incorporate external factors like weather and economic indicators, provide both short-term and long-term projections with high accuracy, adapt to changing trends and patterns over time.
Use cases.
MavGrids caters to both commercial and residential sectors. Commercial helps power companies optimize generation and distribution, enables industries to plan operations during off-peak hours, assists in maintenance scheduling for power infrastructure. Residential empowers consumers with predictive insights for better energy management, supports the integration of smart home technologies, facilitates the adoption of time-of-use pricing models. Tech stack. Our solution leverages cutting-edge technologies, Python for core development, Pandas and NumPy for data manipulation, stats models for SIRIMAX implementation, scikit-learn for additional ML tasks, AWS for cloud deployment, Docker for containerization, Flask for API development, Power BI for visualization. Challenges and limitations. While powerful, our solution does face some challenges. Data quality and availability can impact prediction accuracy. Sudden, unforeseen events, like lockdowns, can disrupt historical patterns, balancing model complexity with interpretability. Computational resources required for real-time, large-scale predictions. We're continuously working to address these limitations and improve our model's robustness. Impacts and benefits. MavGrids promises significant positive impacts: enhanced grid stability and reduced blackout risks, optimized power generation, leading to cost savings and reduced environmental impact, improved integration of renewable energy sources, data-driven decision-making for infrastructure development, empowered consumers with tools for energy efficiency. By providing accurate demand projections, we're paving the way for a smarter, more efficient, and sustainable power system for Delhi. Conclusion. Thank you for your attention. With MavGrids, we're not just predicting the future of power consumption, we're helping to shape a more energy-efficient tomorrow.